We are going to be starting our lesson with the law of sines. So these formulas are also on your formula sheet and they're toward the bottom. This last section, we're going to be talking about all the rest of the formulas. So the law of sines, there's a law of cosines, and there's some area formulas that we're going to be working with. So the first definition that we're going to go over, it's what's called an oblique triangle. Now, an oblique triangle is any triangle as long as it doesn't have a right angle. So let's draw a diagram here. And I'm going to label my three sides, A, B, and C. And we always use lowercase letters for the sides. And for the angles, we use capital letters. So the angle opposite side A is angle A. This angle opposite side B is angle B. And the angle opposite side C is angle C. So in order to solve these triangles, we can solve oblique triangles just like we can solve right triangles. Now, when we have a right triangle, right, we've been learning all sorts of ways to solve right triangles. We use the Pythagorean theorem to help us solve. It should be an equal sign. We use SOHCAHTOA to help us solve. And as long as we know some different combinations, like one of the sides, one of the angles, we can figure out everything else that there is to know about our right triangle. So an oblique triangle, we can't use SOHCAHTOA and we can't use the Pythagorean theorem because one of our angles is not a right angle. So we can use either the law of sines to help us or the law of cosines. And we have to have a certain combination of angles and sides to help us do this. So some combinations that we know, and this is going to remind you hopefully of geometry when you did proofs. We're not doing any proofs, but when you did proofs, with triangles, you had to know different combinations. So one of the combinations that we could know that would help us solve an oblique triangle would be if we know all of the sides. So side, side, side. If we knew two angles and a side, or an angle with a side in the middle and then an angle, so ASA, and then side angle, side. So if we know any of those combinations, then we're good to go and we can use the law of sines. Now the law of sines is just a proportion. So you can use any combination of this proportion. You're not going to use all three. You're going to use two parts. So let's say you know side A, side B, and angle A. You're going to pick the two equations that has most of that filled in. So for example, I would then use the first two fractions in this equation here because I know little a, big A, little b, then I could solve for missing angle B. If I knew another three parts, maybe I know the B's and I know big C, I could solve for little c. Once you get enough information, like let's say you've solved for two of your angles, you can figure out your third angle because you know that angles in a triangle add up to 180. So once you get enough information, you can also use what you know about triangles to help you finish the problem. Okay, so one important thing that we want to also remember is that we want to draw diagrams and we want to make sure everything's drawn correctly. So make sure you label everything and then mark whatever they're giving you, so your givens. Okay, so let's look at number one. Now it says for the triangle pictured below, so I don't have a triangle pictured, so we'll draw it as we see it here. C is 102.3 degrees, B is 28.7 degrees, and side B is 27.4 feet. Find the remaining angle and sides. So when we're drawing our own picture, it doesn't have to be drawn to scale, but I know one of these angles is obtuse. So I'm going to draw a triangle with an obtuse angle. I make it look like this. And the obtuse angle is 102.3 degrees. Okay, I'm going to put B over here. That's an acute angle, 28.7 degrees. So this would be angle A. And we also know, I'm going to switch colors here. I also know side B is 27.4 feet. Find the remaining angle and sides. So I'm going to label what other parts I don't know. I don't know side A, and I don't know side C, and I don't know angle A. So I'm going to start with the easiest ones. I know 2 of my angles here, and if I want to figure out what A is, I can just subtract them from 180. And that gives me 49 degrees. I'm going to mark that off here, 49 degrees. Now, this is not a right triangle, so I can't use SOHCAHTOA. I can't use the Pythagorean theorem. I've got to use the law of sines as long as I have enough information. So what do I know? I know big A. I don't know little a. I know big B and little b. I know big C. So what I know is that I do have a combination that I can use. I want to have one of these fractions totally filled out because in a proportion, right, when we solve a proportion, let me just make something up here. 2 over 4 equals x over 10. We would have all 3 parts except for 1 part missing, and then we could just cross multiply and solve. We want that same combination so that we can solve our proportion. So I've got to know 3 parts so that I can solve for the 4th part. So if I know the complete part of B, I know little b and big B. So if I use this fraction, and I can use either A or C because I almost have enough. So let's do C. I would know 3 parts of these 4 parts of the proportion here. So I'm going to plug in what I know. B is 27.4. Sine of B, so sine of 28.7 equals little c I don't know, and then sine of 102.3. So I'm going to get my calculator out. Now for this I want to be in degree mode. So go to your mode and switch it over to degrees. Okay, so I'm going to do my cross multiply, and I'm going to multiply 27.4 times sine of 102.3. Press enter. Then I'm going to divide by the sine of 28.7. So that's solved for side C. So I'm going to use 3 places, 55.747. And that's in feet. Okay, so I'm going to label that over here, 55.747. Okay, last part, side A. Now I already know B. I actually have all of C now. I'm just going to keep using B though. So 27.4 over sine of 28.7. And I'm going to solve for A. So I'm going to use this one over here. A over sine of A, which is 49. So I'm going to do the same thing on my calculator again. Okay, so I'm going to cross multiply. I'm going to take this 27.4 times sine of 49, press enter, and then divide by the sine of 28.7. A is 43.061 feet. Okay, so we have completely solved the triangle when we know all 3 sides and all 3 angles. Okay, so let's try another one. Number 2. A pole tilts toward the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? Okay, so we got to be careful with our drawing because this can be a little tricky. So let's see, a pole tilts toward the sun. So let's see here, I'm gonna draw the sun. I don't have yellow, but I guess I'll use orange. Here we go, we got the sun. I'm gonna make a pole here that's tilting toward the sun. Okay, so I'm gonna draw it tilting toward the sun a little bit. At 8 degrees from the vertical. So here's the vertical. I'm gonna mark this off at 8 degrees. And it casts a 22-foot shadow. So if we know anything about shadows, right, the shadow would be behind us if the sun is in front of us. So here's my shadow over here. And this is 22 feet. Okay, so the angle of elevation from the tip of the shadow to the top of the pole, so I'm going to draw that in. Tip of the shadow to the top of the pole is 43 degrees. How tall is the pole? So I'm going to label that. We can do A, B, or C. I'm going to call it B. So I've got a pretty good diagram. And let's see, I'm going to label all my parts here. So this would be angle B. I'm going to call 22 feet A. So this would be angle A. And then this will be side C, angle C. So I've got everything drawn. This is the most important part. If you have parts labeled in the wrong direction, then it's going to be a little bit harder to do your work. Okay, so right off the bat, I can figure out this angle right here because this would be 90 degrees plus the 8 that we extended past the vertical. So that would be 98 degrees. And then this angle I could figure out, right, by just subtracting 180 minus 43 minus 98. That gives me 39. Okay, so I've got my 3 angles all done. I just got to find my 2 sides. So with the law of sines, since this is an oblique triangle, as long as I know one combination, I can figure out the rest. So I do know all of A. So I'm going to fill that out. Side A is 22 over the sine of A, which is 39. Equals, now I got to decide, do I want to solve for side C or side B? It doesn't really matter. I'm going to do side C first. So I'm going to do C over the sine of 98. And I'm going to grab my calculator here, and I'm just going to plug it in. So I'm going to cross multiply 22 times the sine of 98. Press enter. Make sure you press enter, because if you don't, your calculator is going to do the order of operations, and it won't do it in the right order. So now I'm going to divide by the sine of 39. That gives me 34.618. And I just realized that I didn't have to solve for that, right? We're not solving the whole triangle. So I guess I did a little bit of extra work. We just want to know how tall the pole is. So I really just need to know what B is. So I'm going to just rewrite that. 22 over the sine of 39 equals B over the sine of 43. So I did extra work. It's fine. Okay, so I'm going to cross multiply here. We've got 22 times the sine of 43. Press enter. Now divide by the sine of 39. 23.841. So my pole is 23.841 feet. And that's about right. If you think about the height of a pole, like a telephone pole, it makes sense that it would be about 20 feet. Okay. So let's go on to question number 3. Okay, so let me draw a triangle for you. You can copy this down. For the triangle below, so I'm going to draw a triangle. We're going to make an oblique triangle. Let's label these angles A, B on the right, C at the top. So let's label everything that they give us. Little a is 22 inches. Little b is 12 inches. Angle A is 42 degrees. Find the remaining sides and angles. Okay, so I just gotta look. Do I have one combination completely filled out? And I do, I know all of A. So I'm gonna use A over the sine of A equals. So I can't solve for B or C because I don't have anything of C, but I do have something of B. So I'm gonna do B. B, which is 12, over the sine of B. So I'm gonna get my calculator out and I'm gonna start plugging in. So I'm gonna do the 12 times the sine of 42 first. Press enter. Divide by the 22. Now that gives me a decimal, so I'm gonna write that down, 0.365. Now that's not equal to big B, that's equal to the sine of big B. So I still have to solve for B. So think about what we've done in trig. If I wanna get rid of sine, I'm gonna use an inverse. So I'm gonna find inverse sine of 0.365. Now on your calculator, you can do this all at once. You can do inverse sine, so second sine, and you can just bring that decimal right down and then press enter. So my angle B is about 21.406 degrees. Okay, so now I can figure out my third angle because I can just subtract from 180. 180 minus 42 minus 21.406. Um, 116.594. That is angle C. Okay, so last step, we got to find little side C. So I'm going to use the combination I started with. I'm going to use A just because I already used it. It's already set up. 22 over the sine of 42. It also makes it easier because if you make a little mistake, you know this one's right because this was a given. So we're looking for C. So side C over the sine of 116.594. I'm going to use my calculator. Just cross multiply. 22 times sine of 116.594. Press enter. Divide by 22. Did I make a mistake somewhere? I think I might have. Nope. Let me just check my work here. C. I have that C should be something else. I'm just going to double check my work here because it looks like I did everything right. I'm just double checking. No, it should be right. Let me just double check here. So 22 times the sine of 116.594. Press enter. Divided by the sine of 42. Oh, there we go. Oh, I forgot. I divided by 22. Okay. Hopefully you caught that. I caught my mistake. So little c is approximately 29.4, that would round to, inches. See, I thought it wouldn't make sense that would be so small. So hopefully you caught my mistake before I did. Okay. So that triangle is completely done. Okay, so let's go to number 4. Show that there is no triangle for which A is 15, B is 25, and big A is 85. So let's draw this. So I've got a triangle. I'm just going to draw a triangle, label it A, B, C. So they're saying that little a is 15, little b is 25, and angle A is 85. So let's try to solve it. I know all of A, so I've got 15 over the sine of 85. And we could find little b or little c, it doesn't matter. Let's start with little b, I guess. So little b is 25. Let's find angle B. So I'm going to go to my calculator. Let's cross multiply. 25 times the sine of 85 divided by 15. I get, now this is sine of B, 1.66. So if I do inverse sine with that decimal, I get an error. Domain. So let's think about this. If on our unit circle, is sine ever equal to 1.6? And that's no, because the unit circle doesn't go past 1. So this triangle would not exist. So you can put a big D on E. Does not exist for this one. So there's no way you could draw a triangle with these measurements and have it work out. Now, if you think about it, that list of triangles that we put on the front, the 4 cases, this is not one of them. This is 2 sides and an angle. So side, side, angle. Read it this way. So side, side, angle, that was not one of our 4 possibilities. And if you remember from geometry, that was one that you couldn't prove. Sometimes you can have an angle where a triangle work out, but you can't guarantee that it's going to work out. Okay, another formula we're going to talk about today is finding a formula for an area of an oblique triangle. Now, normally, if you have a right triangle, right, we know the formula is 1/2 base times height. And it's easy on a right triangle because here's the base and here's the height, and you just solve it, right? But on an oblique triangle, maybe you have a scalene triangle like this. You could pick one of these as your bases, but your height, remember, is the perpendicular. And if you don't know that, it's going to be pretty hard for you to find the area. So there's other formulas for areas that you've never learned with triangles. And as long as you have the right combination of information, you can figure out what the area is. So, and there's 3 different combinations you can have. So area could either equal 1/2 BC sine of A, or 1/2 AB sine of C, or 1/2 AC sine of B. So if you've got any of those combinations, so basically you need 2 sides and an angle, but it has to be inscribed. So if you remember inscribed, the angle has to be between the 2 sides. Okay, so let's try this example here. Find an area of a triangular lot having 2 sides of lengths 90 meters and 52 meters and an included angle of 102 degrees. So I'm going to draw an oblique triangle. I know it has an obtuse angle, so I'm going to make one a little bit bigger than 90. So that angle is included. That means in between 2 sides that are 90 meters and 52 meters. We're going to find the area. So before I do that, I'm going to label the sides. So I'm going to call this angle A. So I'll call this angle B, angle C. So this would be side B, and this would be side C, and this would be side A. So what information do I have? I know angle A. I'm going to make a list over here. I know side B, and I know side C. Okay, so could I find the area? So let's look at these formulas. Which one uses those 3 pieces of information? So I've got angle A, side B, and side C. That would be the first one. So I'm going to write that down. 1/2 BC sine of A. I'm going to plug in what I know. So I know B is 52, C is 90, sine of A, which is 102. Now, you could have labeled your triangle differently. You would have just used a different formula. You'll get the same answer in the end. So I'm going to get my calculator out, and I'm going to type that right in. So that's 1/2 times 52 times 90 times the sine of 102. And again, you want to make sure you're in degree mode. And now this is a parking lot, so it's going to be pretty big. 2,288.865 meters squared. Okay, so that's our first lesson of 2 for the law of sines and cosines.